Plays for an Irish basketball team. Got the points. We got a scatter plot. We need to find the regression line. So the first thing we need to do is what? First thing we need to do. Put them in our table. So if I look at my calculator, we do stats. We do stats. We can see it down here. Right. Stat, edits, and you enter them in. Now I have already entered mine in. You guys probably did the same thing. I entered in 1 through 10 in list 2, or list 1, and list 2 is the points. So list 1 is the game number, and list 2 is the points. Right? It's from this table right down here. Okay. So once I have that, how do I find my regression equation? Okay, so quit out of here, right? Stat, calc,
I'm right here.
For. Okay. Now, if yours just says line right, you hit enter, or you go down here to calculate and hit enter there, and we get our line of best fit. Right? Correct? So our line, our equation for our line then is y equals, right over here, y equals, and you probably round it to 2.05x plus 0.4. Okay. Now since this is basketball points, it's probably okay to have like 2.05. Right? If this was like billions of people in the US, right, or millions of people in the US, you might want to take this down a little further. Alright? But basketball points are typically whole numbers, right, Josh?
Oh, I did that too.
Okay. So, now we have our equation, right? Y equals 2.05x plus 0.4.
Oh, what?
Right? Does that make sense? Are there any questions? All right. The second part of this was to graph, right? Was to graph the equation or graph the line. How do I graph this line?
You plug in 1, 2, 3 for that equation and then get the points with the points.
So Faith says I plug in 1, 2, 3 for the equation, get the points, put it on the line. Does that work? Do I have to use 1, 2, and 3? How many points do you need to make a line?
A lot. 2.
2. You only need 2. Okay. You can pick any number that's on that fits the x-axis. I can pick anything from 0 to 11, plug it into x, get the corresponding y, plot those points, and draw my line. I would say the best two to do are the first one and the last one of what they give you. Okay? So I go by the first and last one they give. What's the first game they give me? 1, right? So I'm going to plug in 1 for x. Okay, so you plug in 1 for x. So you might have done this already. So 2.05 times 1 plus 0.4. What'd you get, Faith? 2.45. Okay. Does that make sense? And then the last game they give me is 10. So I would do 2.05 times 10 plus 0.4. What's that equal? 20.9. Isn't it 20.95? Or 20.9? Okay, we'll go 20.9. All right. So I would use those 2 points to make my line. Okay. Thank you. Does this make sense, guys? So to graph these points, this is my x. Is this an actual y or predicted y? Predicted. This is my x. Actual y or predicted y? Predicted. So I'm going to graph those. I'm going to do it in green so you can see a little better. So I'm going to graph 1, 2.45. So here's 1. It goes. My grid goes from 0 to 5. So 2.45 is probably close to halfway. So that point right there is 1, 2.45. Right? And I'm going to graph 10, 21. Right? 21 is probably a third of the way. So let me write right there. This is 10, 20.9. Right? And I said 21. And now how can I make sure that my graph is correct? What should I do with those two lines? Connect them with a straight edge ruler works fine. Right? Side of your book works okay. Your forearm not so much. All right. Now my ruler is not long enough, so I'm going to I'll approximate here. I know. She got a meter stick out, huh? Oh my goodness, that's terrible. I can't let that stay. That's just too bad. Okay, this will be better. There we go. Should have anticipated not having a ruler and did one of them in the beginning and one in the middle. But I think first and last is the best way. Alright, so does that make sense, guys? Okay. Next question. What conclusion can you draw about Andrea's basketball skills from the slope of her regression line? What's happening here? What's increasing, Jordan? The amount of points she scores, right? Her points per game are increasing. So do you think she's getting better or worse at basketball as the season goes along?
Better.
Better. I know it's kind of taking a rudimentary approach. There might be more things going on, right? She might have fouled a lot in the first couple games, right? But if we're looking just the points per game, we could say that she's probably getting better at basketball because she's scoring more points. How many more points per game does she score? According to her line.
1, 2.
How many long? Oh, you were almost there.
Like 2.
Like 2. She scores 2.05 points more each game. That's what the slope tells us. Okay. Right, does that make sense? Because as x increases by 1, y will increase by 2.05 because you're going to multiply. So Andrea's getting better at basketball. All right, calculate the residual for each point in the data table. All right. Then it says circle the point with the largest positive and largest negative residual. Then draw a line that represents the residual on the graph. So, how do we find residuals? How do we find residuals? I'm erasing my work right here for the predicted. How do we find residuals? Anybody remember, Luis? How do I find a residual?
Add them up. No.
We do not add them up.
Okay, that for the first game, since she scored 2 points,
Yep.
minus 2 from 2.
So you do 2.45 minus 2 or 2 minus 2.45?
2 minus 2.
Okay, good. Because these are my
Prediction.
actuals, right? And the ones I calculate with my equation are the predictions. So to find my first residual here, we take 2 and subtract 2.45. So it looks like this, 2 minus 2.45. Now you probably thank me for that extra space on the table, right? Helps you guys keep your work organized. So 2 minus 2.45, what does that equal?
Negative 4.5.
Ooh, close.
5.5.
Negative 0.45. And if we look,
That's what I meant.
if we look at this dot, I know it's a big dot, but that dot's just a little bit below the line, right?
Yeah.
Because is this a big residual or a small residual?
Small.
Small. It's a small error, right? There's only a small difference between the actual and predicted. Okay. Now, I know we could go through into each of these, but I'm pretty sure you guys already did that, right?
Yes.
Okay. Let's check again with the last one. So actual minus predicted, 21 minus, wow, it's not 2.09, it's 20.9.
0.1.
What is it?
0.1.
0.1. So subtract these and we get 0.1. And if we look, oh, maybe my line is off. Maybe my line is off because this should be just, this right here should be just above the line. So maybe my line's not exactly where it needs to be. Right? But it's close. Okay? Are there any questions? Okay, that's bugging me now. I want to fix it. Anybody else like me that want to fix theirs?
Fix their what?
Fix their line. Oh, I need a ruler.
I didn't round to the hundreds. I can't see it.
There you go. There we go. Okay. That's better now. Because our points, right? This residual right here is a positive residual, so that point needs to be above the line. So it was bugging me. I needed to have my point above the line. Sorry about that. Little personality quirk there. All right. A good way to check your residuals. All right, if you're worried that you did your residuals incorrect, you can check it with your friend. Or if I look on here, if my residual in here is a negative number, where should the point be?
On the bottom of the line.
On the bottom line, good. If my residual over here is a positive number, where should the point be?
Above.
Above. So you can check your work that way. Okay? Now, the rest of part C. Circle the point with the largest positive residual. What's the x value for the largest positive residual? Anybody know? What is it, Unique? 6. This one is the largest positive residual. Oh, one is blue. This one is the largest positive residual. Why?
Because it's furthest away from the line.
Good. And it's positive because it's
Above the line.
above. And the line that represents the residual is that line. Did everybody follow directions to draw that line? No. Okay, draw it on there now. Okay. While you're drawing down there, look for the largest negative residual. You found it already that quick? My goodness. X value for the largest negative residual, someone besides Jovanique. What is it, Bruno? 8. And this is the largest negative residual because it's the furthest from the line, and it is?
Negative.
Negative. How do you know it's negative?
From the bottom.
On the bottom. And that means it's negative because that means the actual was bigger, or sorry, the actual was smaller than the predicted. So actual minus predicted would be negative. And the green line represents our predicted values. Does that make sense? Are there any questions? Okay. Last part. How many points do you think Andrea will score in her 11th game? Okay. How many points will Andrea score in her 11th game? Now, is this predicted? Is this predicted or is this actual?
Predicted.
Predicted. So where do I get my predicted values? Do I use the equation or the table? Equation, Faith and Andrea. The equation tells us our predicted values, right?
Right.
So if I want to find our prediction for the 11th game, what do I do with the equation?
Put in the
You
line.
put 11 in it for X.
Okay, good. We plug 11 in for X. So if we plug 11 in for X, we get, whoa, that led me. 2.05 times 11 plus, oh, that's not 11, plus 0.4, right? 2.05 times 11 plus 4, plus 0.4. Bruno, you said it was what? 22.95.
Or you could have just looked at the whole prediction list.
Okay.
You can see they're going up by like 2.5.
Okay, so you could say it's going to be about 23?
Yeah.
Yeah, okay. You could also, okay, I don't know how to use this table for it because these have pretty wide intervals, but you could also look where the line is when it's when X is 11. That would work too. But that's also dependent on you being able to draw your line straight, which I obviously couldn't earlier. All right, are there any questions about this problem? Any questions? Okay. One more thing I want to teach you, and then we're going to try the next example. Okay. There's this cool thing called a Centroid. What it is, it's a little robot that I use to grade your tests. No, that's a joke. Okay. But there is this cool thing called the Centroid. Now, when I say Centroid, what do you guys think? What's the first word that comes to mind?
Money.
Center, right? The send money. Goodness. A little greedy. All right. So, Centroid, a lot of you are probably thinking the word center, right?
Yeah.
Take off the OID, put an E in there, we got center, right? Okay. The centroid is the center of the data. Okay? It is the center of the data. So you can write center of data. I know there's not a lot of room on your paper. Maybe you want to take old-fashioned notes, line paper. Maybe over on the bottom right corner somewhere. The centroid is the center of the data. Okay? The way we find the centroid is we need to figure out, the centroid is an ordered pair. And we find it by finding the average x as our x coordinate and the average y as the y coordinate. So that's how you find the centroid. It's the average x comma average y. Okay. Does anybody remember how to find average?
Would you add them all up and subtract it by
Not subtract. You're close though.
No, add them all up and then divide by
The numbers. The amount. Yeah.
Okay, good. So we add them all up. So if I want to find my average x, we add up all these x's, right?
and you divide by 10?
Divide by 10 because there's 10 of them. To find our average y, we add up all these, right? Then divide by 10 to find our average y. So let's find them real quick. See if I can put this where we can see our. So our x's. This is the way still. Our x's were 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and I forgot a plus sign back here. I did too. It's not 12.
So mine is 9.
Okay. So I got 1 plus 2 plus 3 plus 4 plus 7 plus 8 plus 9 plus 10. Hit enter and we get 55. So now to find the average, we do 55 divided by 10 because we have 10 terms, right? So that means my average x is 5.5. My average x is 5.5. Then to find our average y, we add up all of our points. 2 plus 4 plus 5 plus 9 plus 10 plus 20 plus 16. Thank you. Thank you, Faith. Okay. And we get 117, right? Now how many games did she play? 10. So we do 117 divided by?
11.
Divide by 10. Okay. So that means over these first 10 games, her average is 11.7. Now she scored above 11.7. She scored below 11.7. But the center is 11.7. So our centroid is 5.5, 11.7. Now, since this is the centroid, it is the center of the data. Where will it be on our graph? In the middle. Will it be? Where will it be relative to the line of best fit? What do you guys think? You think it's on the line, Faith? Who agrees with Faith it's going to be on the line? Okay, you don't have faith in Faith, huh? All right. Well, let's try something out then. Let's look at 5.5, 11.7. So if I go over here, 5.5. 5.5 is in between 5 and 6, right? And I go up to my line. It's above 10, right? So it could be 11.7, couldn't it? So I'm going to put a little dot right there. That kind of looks like it might be 5.5, 11.7. But that's just an approximation, isn't it? Make the dot a little bigger so you can see the back. Okay. That's just an approximation because my graph is an approximation. I drew with a line, right? How can I be sure it's on that line?
If you do the residual.
Nope. Do what, Bruno? Do the equation. Plug in what into my equation? 5.5. So if I take our equation, which was 2.05, right?
Yes.
Times 5.5 plus 0.4, and I hit enter, we get 11.675. 11.7. So the center right down the line. Are there any questions?
Negative.
No.
Yeah, where was this?
Okay.
What